All right, so let's take a look at the exponential and logarithm problems now. So they give us this function here, right? And it's asking us what basically does it mean? What's the percent that comes from this equation? So it helps to know that the breakdown is usually the principal, that's what you start with, right? And the front number. Okay, so in this case, the principal is 1,500. Right? Then it's usually 1 and then plus the interest rate. And yeah, interest rate. As a decimal, right? So in this particular problem, it's going to be 1 plus 0.045, right? And then it's just raised to the t power here for both of them per time. Okay. So the interest rate that we're concerned about is really this number, 0.045, which as a percent is 4.5 or 4.50%, because you just don't put percents in the equation, you have to change it into decimals. So there is our answer. And you can use this formula for any type of compounding except for compounding continuously. That's when you use the E. But if we're compounding monthly, it'd just be this divided by 12, or quarterly be divided by 4. But this is the general formula for all those types of problems. Now let's look at some logarithm problems. So first, it's just converting the logarithm into exponential form into logarithm form. Just remember, with logarithm, the answer is the exponent. So it's going to equal 6. So it actually kind of narrows it down to a right away, but you can see how the rest goes. The base of our exponent here is the base of the logarithm. So we'll have log of 3, right, log base 3 of 729 as our final answer. But just remember, all these problems have to do with solving an equation where the exponent is the answer. 35. What is true about this particular equation? So it helps to know kind of what these graphs look like. Exponential graphs usually look something like this. Start off slow and then they grow really fast, right? A few things about this is that it has a +1, which means it's going to be moving, translating to the left 1, but also has this negative, right? Which a negative at this point is going to make it flip over the y-axis. So let's say this is the let's say y-axis right here. Let's say that's what the graph normally looks like, right? With a negative x, it's going to look something like this. Going to be going like this. So just visualizing or writing this out will help a lot. So first of all, we can just go through the answers. A, the range is y less than 0, but we can clearly see that it's above 0, right? This is the y-axis, and it's greater than that. So if this was greater than that, would be true, so that's not right. Function is decreasing. Let's see here. Yeah, as you go from left to right, it is getting smaller. That's true. Y-intercept is 1. That implies it goes through the point 0, 1. But if you plug in 0 into here, right, you would have 5 to the 0 plus 1, which equals 5. So the y-intercept is actually, a real one is going to be 0, 5. So that's not it. And as x gets bigger, goes to infinity, y also goes to infinity. But as we can see here, the y is not going towards infinity, it's going towards 0 as x gets bigger. So yeah, that's not it. So it does look like our answer is just B. The fact that from left to right, it just gets smaller. It's decreasing. And let's solve an equation with exponents. So let's go ahead and add 210 on both sides. All right, so we have 3x plus 1 equals 216. Now, if you've done enough assignments, you already know that 216 is the same as 6 to the third power. So that piece of information is very useful right here. So since the bases are equal, so are the exponents. We want to know when does 3x plus 1 equal 3, so we just need to solve that equation. So do a little bit of arithmetic here, some algebra. So we'll have 3x equals 2, so x equals 2/3. D. Let's go down to 37 here. So we have some natural logs, which means we're involving e, letter e. So this is, we'll call that a logarithm with a base of e. That's the same as natural log. We don't have to, we have a special notation just for this situation. But all the properties and everything work the same as log. So if we're adding two exponents, really, because these are each exponent rules, that is the same as multiplying them. 2x times x. And that comes from, you might recall, if you're doing this, right, how do you simplify this? You end up adding them. Right? So that's what's going on here. The two exponents are being added, which is the same as if you multiply them. It comes from multiplying. That's why this changed from addition to multiplication. We're doing this backwards. We're usually doing it, you know, we have two exponents and we add them together, and we're just going the other direction. Okay, equals 4. So that's going to be 2x squared, right? 2x times x equals 4. And then we can raise both sides to the e power, right? So we're going to raise everything to the e power. And the base of e, because natural log has a base of e, right? What happens is that these end up canceling each other out right here. So we end up with 2x squared equals e to the 4th. So just remember, raising something to the e power and a natural log are inverses. They do cancel one another out. And then we just have to solve this remaining part right here. So if we divide, let's see here, both sides by 2, we'll have, let's see, well, actually now I can see the answer. I guess we just need to stop right there. So the first answer right here, A, is actually that, 2x squared equals e to the 4th. So we don't have to go through and solve for x. There we go. All right, let's go ahead and go to 38. Almost done with the exponentials. So very similar to a previous problem, is that we're looking at a population of 2,000. So that's the principal. You can see how these are all 2,000, but we have various different amounts here. So the key is, how do you show a declining rate of 5% a year? So same idea. It's principal, right, times 1, and for declining, it's subtraction. So the fact that it's declining, we're going to subtract the rate. And that's going to be raised to the x power. So in this case, 5%, right, 5% is, that's decimal, 0.05. So we're going to have 2,000 times 1 minus 0.05 to the x, and 1 minus 0.05 is simply 0.95. That's how we get the answer of C. So you can see, if you're going down or declining 5% every year, that means you're keeping 95%. So the function always shows what you're actually growing by, not what you're decreasing by. So if you're decreasing by 5%, that means you're still increasing by 0.95. Okay, so go do a little bit more logarithms here. So very similar before, when you were, let's say, dividing, right, you probably learned to subtract those exponents. So since we're subtracting two logarithms, which are like two exponents, right, that's the same as dividing here. So this is going to be log of 3 of the first divided by the second equals 2. You can raise both sides to the third power, right? Cancel out the log. So we have 3x plus 1, or x minus 1, equals 3 to the second, which is 9. And then we just have to solve this equation. So that's going to be, let's see here, 3x plus 1 equals 9 times x minus 1 if I multiply both sides by x minus 1. Right? Cancels out. And then just do a little arithmetic here to solve the rest. Variables to one side, numbers to the other. So we'll have, let's see here, if I subtract 9x and subtract 1, end up with, let's see here, 3 minus 9, which is negative 6, which will equal negative 9 minus 1, which is negative 10, and then divide both sides by negative 6. So we'll end up with positive 5/3. We'll cancel out, and then that reduces by 2. So positive 5/3. A. And a little bit more logarithms. Let's see here. Just convert this to, solve for x. Okay, so we need to get x by itself. So let's start by, let me write this down here. And this is what logarithms are for. It's solving an equation when the variable is an exponent. So by taking just the log of both sides, general log of both sides, what happens is that this becomes a coefficient. It goes down in front. So you end up with 2x log of z on the right, and the left is just log of y. So that's what the logarithm does. It takes something from being an exponent and brings it down in line with everything else. And then we can just go ahead and solve for x. So we want to divide by 2, right? Because we're trying to get x by itself, so we need to get rid of the 2, and we need to divide by log of z. Now we'll get rid of both of those. So 2 log of z, same thing on both sides. So x must equal this right here. Log of y divided by 2 log of z, which would be c. And one more exponential problem. So let's get the base and exponent by itself, add 31. So 6 to the 4x minus 1 equals 36. Okay, well that makes it a lot easier because I can rewrite 36 in the base over here in base 6. So that's going to be 6 to the second. So since the bases are equal, so are the exponents. So 4x minus 1 does equal 2. It means 4x equals 3. I'm going to add 1 to both sides, which means x equals 3/4 when you divide both sides by 4. So D. All right, I think that concludes the exponents and logarithms section.